get to do the groundhog simulations, which are really cool. I really enjoyed that mini project because that was cool. So that's one use that obviously I think we already did that, but that's one use of simulations that we can do. But here we can do a little dice roll. We're making a range of 6 so that we can roll our 6-sided dice. But we're going to be doing something similar to this in Lab 6, but with a 20-sided dice, like simulating for Dungeons and Dragons. And in that code, we're going to be using a modifier. So here I'm just doing another 6-sided dice roll, but with the added modifier here at the end. And you can just change that if you wanted to, but this will add whatever onto the random dice roll. And just because I saw some students were confused what a modifier was, it was just adding like extra bonus points onto the dice roll, making it larger on average than like your regular dice roll. Here, let me get rid of this clear all outputs so that we can have a fresh start here. But here's an example of a for loop, just reiterating again like what a for loop is. Let me run this again, make sure this will run. But here we have different types of pizza, cheese and margarita, and this is saying like for the pizzas in this string that we made here of these different pizzas, it will this is just going to print our pizza types here. If I run just this section, let me move that here. I'll just run just this section here. That'll just print our pizza types. But this loop down here will allow you to do the for loop, adding this little F string here that pizzas are ready to serve for all the 3 different types of pizza. So that's
I
basically what
like
the
that.
yeah, it'll just add whatever onto um you want or for here we're doing pizza types, but the for loop basically does that. Here we're just using an F string, which is good.
Now, Riley, what if someone wanted a pepperoni pizza? How would you do that?
You could add pepperoni here as well. I'm gonna just call it like a meat pizza because
Yeah.
I'm
Yeah.
bad at something. But if they wanted a meat pizza, you could also add that as well onto the just add it onto pizza types.
Super.
Yeah. This is a string, but you can also do a for loop with numbers as well, or integers. Here we have it with prices. We just got different prices of pizza here, and then if we wanted to add the price with tax, we can do a for loop timesing the price by like I guess 1.3, and then that'll give us our new price. So that's basically how a for loop works in the most simple sense. Obviously you can make them more complicated. Here we have our we're creating our function for dice rolling. I mean, we did it up here, but this is just a way you could do it as a function, just showing how a function works. We're defining it here, and then we got our dice, and we're randomly rolling it, printing out our array of numbers. Here's a function for finding the frequency of numbers in an array. And this is similar to what we're going to be doing in Lab 6, but instead of finding the frequency of numbers, you're finding the frequency of letters in a dictionary. So dictionary is something we are going to get into in this lab. So this part we know is defining our function, and then this is just opening an empty library for us to put stuff in. And then this is just saying for the numbers that we're going to be defining for the digits in the numbers, and we're making it a string here because we're counting the numbers and we need to make it a string. That's just what the string is doing here. And then we're going to get our digits, and we're just adding 1 for each. This is just adding 1 for each digit, adding them up. So here it's counting our digits, an example of some numbers, and then when we use our function, we can use any numbers we want. It's just the numbers I picked, and then we have 1 we have 3, and then 2 we have 2 twos, and 3 threes, and et cetera, et cetera. But that's a way you can do that for numbers, but we're going to be doing that for words in the
Nice
lab.
example. Yeah.
Yeah. Um, and then just a refresher on how to use a 5-number sum, which is important to understand. So I just made some random column with some numbers here, little table with some numbers. And it's going to take that table and that column and just return our min and max, mean, median, standard deviation. So that's really great to use when you do your final projects. If you just need something simple to print out some numbers about your data, just reiterating that's how you do your 5-number sum, and that's what it means. I know it looks a little intimidating, but it's really not too complicated. And then here's just another simple what do you call that, a function for, like, this is similar to what's going to be in lab 6 when we're looking at different code for DNA. We got different repeating letters here, like the 4 letters of DNA. And what this function is doing is counting the number of, every time we see a G or a C come out, we're gonna add them together. That's basically what this is saying here, just adding in sequence. And then when we return it, it's going to give us this count here, this GC count divided by len, which the len of the sequence is going to give us the total number of letters. So this is the number of G and C divided by the total number. And here we just have like some random DNA sequences that we'd be given. And then our F string is just going to print out after we apply our function. Our F string is going to print out the quantity, the fraction of G and C in the string. So that's basically what that's going to look like in the lab, a more simplified version, but that's basically what we're going to be doing in lab 6. Hopefully that was helpful.
Wow, that was a tour de force. Quite impressive, very concise, but lots of information, really information packed there.